Okay, I forgot. Yeah, so I just started recording. So yeah, maybe we can organize a second call. So as I said in the email, there are a lot of new members in the brigade. So we'd like to start with a brief introduction of each one, and I think we can also reintroduce ourselves for the new members. So I'll start, and then I'd like the other brigade members to briefly introduce themselves. So as you may know, my name is Carmelo Cascone. I'm an engineer at ONF. I'm the leader of the P4 Brigade, and and I think that's all. Yi, what about you?
Yeah, okay. Hello, everyone. My name is Yi Zhen, and I'm from NCTU. Currently, I'm internship in ON.Lab, and I work with Carmelo. They have developed the P4 and the program independent framework in ONOS. And nice to meet you. Yeah, that's it.
Thank you, Yi. Who's next?
I can be the next.
Who's there?
Yeah, this is Serkan talking.
Hi, Serkan.
Hi, everybody. So we are the newest members of the P4 Brigade, and thank you, everyone. So I work for Netsia as an engineer, and previous that I have an experience using ONOS and also have knowledge about P4 and its use cases. And so a few months ago, we started to learn P4, and our interns, Mehmet and Ekber, who are on the call right now, also helped us. And also, I want to give you a short summary who we are, very short. So Netsia is an applied research organization around 5G technologies. It's based on Silicon Valley, but we are based in Turkey right now. And the Netsia is fully owned by Argela Technologies. So as Netsia, we are contributing in some ONF projects, which are M-Court and A-Court. And in 2015, we have started a national SDN and NFV project, which is called as MIDAT. And in that project, we have used ONOS as the network operating system. So there are plenty of developers experienced in ONOS. That is all from me.
Thank you, Serkan.
Thank you.
Anyone else? Yeah, maybe Phil.
Hello.
Okay, Abby. Yes, please.
Yes. I am Abby. I engineer for H-Core, and I am the field to learn how to set up the ONOS and the P4 and do the POC for the customer.
Okay, that's great. That's great. Thank you, Abby and Phil. And thank you for joining even if it's so late over there.
Okay.
Anyone else from ONF?
Maybe John one.
See a number of people from ONF. Do you guys want to introduce yourself to the new members?
Yeah.
Okay, I will do.
All right, John.
So, hi. Hey, I'm Jonghan. I'm working as an intern at ONF. I'm originally from Post-Tech Korea as a graduate student. So I'm also working with the Carmelo to develop P4 stuff. I'm interested in the INT, network telemetry stuff. Okay, nice to see you.
Thank you, Jongwon.
Thank you.
You can go next. My name is Brian O'Connor. I'm an engineer at ONF.
Brian, we lost you. Okay, we lost Brian. I think his home connection these days is not very good. Okay, maybe Brian? Okay, we lost you. Yan, do you want to introduce yourself?
Hi, I'm Yan Chow. I work at ONF, and I'm also working in the brigade.
Okay, thank you. Anyone else? I'm not going to call each one, but like if you'd like to introduce yourself, if you plan on working in the brigade, it would be great if you can introduce yourself now.
Carmelo, my audio cut out. Did you hear my introduction or no?
No, not at all. Just engineering.
Oh, great. Yeah. So I've been working on ONOS for the past couple of years, and I also work on the Mininet project. I've been involved in the P4 effort for the last couple of months.
Okay, thank you.
I think Esin is having some difficulties in sound problems, so he is also from Netsia and work as an architect in Netsia. So he's a experienced ONOS developer, and also I see in the call Mehmet and Ekber. We worked together. They worked in Netsia as intern last summer.
Okay, great. So if I'm not wrong, there are 5 new members from Netsia that joined, right?
Yes, Alper is supposed to be here also, but he had a surgery, eye surgery.
Okay.
So he could not be here.
Okay.
Hi, my name is Mario. I'm from Cisco, and I'm actually not really currently working on ONOS, but I'm working on P4, and I'm curious to see what is going on in ONOS regarding P4, how it has been supported.
Okay, that's great, Mario. Nice to meet you. Thank you for joining.
Nice to meet you.
All right. Anyone else?
Dosen.
Hi, Dosen.
Dosen, yes. Nice to meet you. I come from Taiwan. I consider ONOS 1 year ago. I study in PhD program. I consider before. I hope in this brigade give me some knowledge about before. Thank you.
Okay, thank you, Dosen. Thank you for joining. Nice to meet you. All right.
There's also one from ICT.
Nate. Yeah. Hey, Nate. Do you want to introduce yourself?
Okay. Hey, I'm Nate. I'm from NZTU Taiwan, and I have experience in develop ONOS app and M core and mobile code. Yeah, and I will study P4 right now because I think programming is very interesting. Thank you.
Okay, thank you. There's a lot of people calling from Taiwan. Maybe we should change the time of this call.
Yes, and Kevin is from Taiwan too, but his connection has some problems, so he can talk now.
Okay. Also, Phil Wang just wrote to the chat.
Phil just told me his microphone is some
Okay, yeah. I mean, Phil is also from EdgeCore. I think Abby introduced him. Yeah, thank you guys for joining, even if it's so late. So maybe we can move on. I don't know if there's anyone else would like to introduce himself. But otherwise, I think it's time to talk about the roadmap. Okay, so talking about the roadmap, before introducing the new use cases for the new members, as probably many of you already know, for the past, I guess, 4 months, maybe 3 months, I'm not sure. We started like mid-April. Yeah, I mean, for the past months, we've been working on adding support for P4 runtime in ONOS. So P4 runtime is a runtime control protocol developed by the P4.org API working group. Was an initial collaboration. Initially, it was a collaboration between, I guess, Google and Barefoot. Now it's an official P4.org open source project. So yeah, in the past months, we added support for P4 runtime in ONOS, both at the southbound in terms of capability of ONOS of speaking P4 runtime as a control protocol, and also the platform level. We did some enhancement in order for applications to control, ideally any P4 program. If you're not familiar with this work, I suggest to have a look at the P4 Brigade homepage. I'm going to put the link on the doc here. So if you scroll down, there's a section called Learn More, right? You can see the roadmap. There's a section called Learn More in which we have few presentations and slides that describe the work we'll be doing and the way we support both P4 and P4 runtime in ONOS. So yeah, I invite you, if you're not familiar with this work, to have a look. So now that we have more or less stable support for P4 runtime in ONOS, it's time to work on use cases of this P4 runtime support in ONOS. And we have planned to work on two use cases that are called Fabric.P4 and INT, for which we're seeking community help. There's also other, let's say, topics, areas in which we're looking for help, such as documentation and unit tests, but we'll talk about this later. So now I would like to introduce Yi Tsang from ONF that has been doing some work on Fabric.P4. Yi, do you want to use my laptop or you want to use
my laptop?
Okay, so I should be able to, yeah. Yes.
Maybe the organizer, you can
share
my screen.
I'll try to make presenter, right?
Yeah.
Yeah.
I think so.
Yeah, okay, so you can find the slide at that link. He's going to talk about Fabric.P4. While I'm making presenter, very high level, Fabric is a very exciting project. If you're familiar with other ONF projects like Chord, Chord is based on Fabric. Fabric is, let's say, the term we use to refer to the way we control the network that connects both the access device and the servers, the way we move packets between VNFs and the access network. And we're actually planning of having a P4-based Fabric. So please, the floor is yours.
Okay, hello everyone. I will introduce the Fabric.P4. And okay. Everyone can see my pointer. Okay. I think before the P4's part, let me introduce the Fabric, leaf spine Fabric we use in Chord, and the Trellis project we use in Chord first. So what is Trellis? So Trellis is a Unicode combination of the underlay leaf and overlay leaf spine. So we use the Trellis. We provide the overlay and the underlay control to control the white box switch, which this topology, which we call leaf spine topology, and we also control the OVS for the overlay network. So the main application of the Trellis is segment routing application, which provides L2, L3, can provide L2, L3 forwarding basic on the configuration, host store, and the route store. And then so currently the Trellis project is based on the, the underlay control is based on the white box switch with Broadcom chip with OFDPA pipeline. So what is OFDPA? So OFDPA is a software component that provides a hardware adaptation there between the OpenFlow and the ASIC. So we have control, and we use the OpenFlow protocol to program the ASIC Broadcom chip. Because the Broadcom chip may have different implementation of the OpenFlow, so they provide a OpenFlow data plane abstraction here, and so we can use the OpenFlow to program the ASIC. So let's talk about the OFDPA pipeline. What's inside the OFDPA and what's their pipeline? So this is a simplified version of the OFDPA pipeline. Actually, the real open OFDPA pipeline, they provide I think bunch of tables, maybe 20 or 30, but this is just simplified version of DP pipeline, and we use this sets of the tables in the trace project, actually in the underlay control. So, so for different tables may have a different match and action. For example, the VLAN table can only match the input port and the VLAN. And for example, the bridging table can only match the MAC address and the VLAN ID. And for each table, they have different action. For example, the VLAN table can only modify the VLAN ID and some VRF metadata, and the policy HCL policy table can do the wildcard match action and do some packing action. And for group, they also have some limitation. For example, L2 flag group can only provide O type action. You need to execute the O action bucket in the group. And for L2 interface group, we can only provide the indirect bucket, can only execute one bucket. And they have different action type. For example, L2 flag group can only do something like group action and point to other groups, and L2 interface group can only do the output and some action. And also they have some limitation of the group ID. For example, if you want to create L2 interface group for port 10 with beta 100, you need to give the group ID 0x00640001. Yeah, so there are a lot of limitation of DP pipeline. Let me give some example of DP pipeline and we use in trace. You can find this example in the Court wiki here. So if we want to do the L2 unicast, first we need to because we need to do the training, group training, we need to point the flow table to the group table. Also, so the right hand side here are group tables, and according to OFDPA limit spec, you need to create a group first, then point the group from the tables. So first we need to create the L2 interface group, and we need to install some flows into the bridging table, then program some other tables. Yeah, so so this is just a simple table, simple example of DPA. But if we take a look some more complex example, for example, L3 unicast, we need to use a bunch of group tables and tables. You need to create L2 interface group, MPI stable group, and the ECFP group. And this you need to create this first, and this, and then this and this. And you cannot create then in parallel. Yeah, so the difficult part to control of the pipeline is to doing the group training, and you need to wait until the latest group then create next group. So also the relationship between groups may be one to many or one to one, or sometimes you can point like this group and this group to send L2 interface group. So you can point many to one or something like that. And so to support different kinds of, because ONOS can support different kinds of pipeline, we have a very nice abstraction in southbound. And also we provide a nice abstraction in northbound called flow objective. We use the flow objective. Slide for the flow objective? Yeah, so basically the flow objective, you don't need to care about the pipeline. If you use the forward system in northbound in the ONOS, you need to set the flow table, and you need to set the group table, group ID for the group, and you need to set for the collection. By using flow object system, you just need to care about the white match to do Yeah, sure. Yeah, sure. Sorry. Sorry.
Seems there is some echo.
Is Brian talking?
Yeah, there is some echo from Brian. No more echo. Okay, you can go.
Okay. Okay. So you just need to care about what to do and what's the next step. For example, if for the L2 unicast example, we just need to create. For example, we want to fill the filtering objective is permissible deny the packet to the pipeline. So we use these two tables to filter out the packet. So we create filtering objective, and the pipeline will translate the filtering rules to these two table flow rules and install it. Then we may create the next objective, and it will help you to create the. For example, we want to create next objective with the BLAN 100 and the output 10. It will help you to create the L2 interface group with the output bucket automatically. And we create a forwarding objective with, for example, the MAC address and the VLAN. It will help you to convert it to the bridging table. And also, we need to give the next ID for the forwarding objective. So the forwarding objective will point to this next objective, and the bridging table will automatically point to this L2 interface group. So with pipeliner, with different pipeliner, we don't need to care about the pipeline. And okay, so don't need to care about the pipeline. So we just need to create the very high level abstraction. But it's still very complex because the pipeline become very complex to maintain, because we need to maintain all the kind of actions like group training and stuff. So the problem, as I mentioned, the complexity of pipeline is very high. A lot of table limits and group training. For example, you cannot do the VLAN translation with multicast because the limit of DPA pipeline, and because this complexity, it's hard to add new feature to the Trellis project or the pipeliner. And there are a lot of version of DPA, for example, OPT 2 and OPT 3, and there are a lot of different kinds of broadcom chip to support off DPA and have some limits. If you take a look at the off DPA 3 and the pipeline inside the ONOS code base, you might find different kinds of DPA pipeliner, and to support different kinds of limit.
Quick question. You're saying that even if there's a common abstraction of DPA, if below I have a different version of Broadcom chip, the way I use of DPA might be different?
So I'm not sure it's Charles put. I think Charles already put to the ONOS code base. There are different kinds of Broadcom chip, different version. Different kind of Broadcom chip. They all support of DPA. For example, version 3, but for example, the ACL table cannot. The limits different. For example, the newest version of chip cannot match the UDP source.
Okay.
So there's some kinds of limit.
Okay, so this is very important, because even if there is, let's say, a logical view of the underlying physical pipeline, which is FDPA, it seems that it's still hard to get a formal representation of that pipeline, right? So that's why we would like to use P4 to define our own pipeline and have a formal representation of that.
Yeah, so if you take to get the pipeline of DPA, you can see a lot of modification to fit the different kind of version and chip.
Yeah.
Okay. Let me quickly introduce the fabric. So sorry, before the pipeline, let me introduce the development, the way we develop now. So currently, we develop the SDN application according to the fixed function switch. For example, we develop different pipeline for the different kind of chip and the switch. But with P4, we can revert this direction. We can we can program the switch according to the SDN application. So following this way, we developed the fabric. We have a prototype and the design of the fabric.p4. So let's take a look at the objective. As I mentioned, we have a three type of objective: routing, forwarding, and the next. So we, according to this objective, we can create different kinds of control block inside the P4 code or the P4 pipeline for different purpose. For example, the routing control can routing out the packet into the pipeline according to the routing objective role, and the forwarding control is based on the forwarding objective, and next control is based on next objective to do different kinds of next action. So this is the initial design of the fabric.p4. So for the routing control, we just based on our use case. What we use, for example, we use the input port and the VLAN to routing out the packet by using routing objective, and then we use the we have different kinds of use case. For example, we have a bridging use case, MPRS, and the IPv4 unicast smart case, IPv6 unicast smart case use case. This tables is based on our use case in Trellis. Also, we have an SCL table to do the final decision of the packet processing. For example, we want to drop the packet or the packet to the controller. And we have a next control to do different kinds of next action. For example, we can do the simple. This three type of next table is based on the next object type of next objective. If you take a look at the next objective, you can see this. Actually, there's a four types, but currently we implement these three types.
So hash in this case will be like equal cosmos, something like ECMP.
Yeah, ECMP okay. Or WCMP if you put the waves. Yeah, okay. And
so basically the hash table and the broadcast table, or the hash table will be based on P4 action profiles.
Yeah,
and the broadcast one will be.
Okay, so
you need to support a different level there, right?
Yeah, because currently the broadcast cannot support directly by using a P4 runtime. We may use different kinds of
API to program the broadcast. Yes.
Yeah, but I think that also the simple can use the action profile. You just need to put the one
the action number. Okay.
Yeah, here. So, so basically, this is the high level view of the fabric.p4, but there's still some improvement. For example, we need to put the port counter and something like the packet out, packing support.
There's a lot of this.
Yeah. Okay. So let me quick talk about our roadmap. So the phase one, current phase is making work with the segment routing. Maybe the Trellis, some question on the Trellis, like segment routing, router advertisement, and the DHCP relay, and also I think that the main application, this three main application provide the L2 and L3 forwarding, and the phase two is to optimize the pipeline for core use case. For example, the R core use queuing queue, and the trace also handle the overlay networking handling by using VXTEN. Because we use P4, we can define the parser to pass like level 5, level 6. So we can pass the VXTEN, the VID or something else inside there. And also we can reduce the pipeline complexity, because currently the fabric.p4 we will install it to the both list and spine switch. But for the list spine switch, they have different like mesh action, because currently we use for the spine switch we use in Trellis project. Currently we just mesh the MPRS and do the output to the right leaf. Okay.
Oh, just to clarify about this part, if it's not clear. So for phase one, we plan on mostly working at the P4 code level, minimizing the changes required at the ONOS application level, right? So we want to make sure that we can have existing application, at least have the existing segment routing application work with this fabric.p4 program. Once we assess that we're able to do that, we're able to reproduce all the required functionality of the segment routing application, then we can proceed to optimize that, right? So we optimized both the P4 program, but also we changed code at the ONOS level. So we changed both the application, the driver layer, based on core use cases, as he was mentioning.
Yeah. Okay. So the last page I have some tests. So we have some initial tests. I'll finish this part. For example, investigate the requirement for the trellis, and I will publish the design document, and also I will move the prototype to the ONOS code base, include some building rules, bug rules.
So for example, in this case, other brigade members can help, for example, review the document, the P4 design document, and also the P4 code that we have right now. That, by the way, it's just a draft, right? We never tested the P4 code. Yeah. Okay.
Yeah. So there are some high priority works text. For example, we want to put the port counter and the PKIO. So currently, the prototype of P4 Fabric.py doesn't support the PKIO action. It's very important action we need to support.
With packet.io, you mean SDN like packet in, packet out?
Yeah, yeah.
Okay, like in OpenFlow, like sending a packet.
Because we need to support different kinds of use case in Trellis. We need to support PKIO, packet in, packet out, and also the interpreter to translate the, for example, translate the for rows and translate the packet in, packet out the packet. And also the pipeliner. So the pipeline is designed for the Fabric.py to provide a very simple translation to different.
So the pipeliner, what enables, what makes possible using the same segment routing application, right? Without changing it to work on the new pipeline, right? So the pipeliner is the translation layer between the flow objective and in this case the Fabric.py pipeline.
Because currently the segment routing and the DHCP array we use the flow objective, so we still need the pipeline to translate the flow objective to the rows we want to install.
Okay.
And we have some one lower priority task is to improve, as I mentioned, I think that is for the phase 2 to put other protocol support. Yeah, so that's it. That's the Fabric.py.
Okay. Thank you very much, Xi.
Thank you.
I don't know if there's any question. Maybe to recap a little bit. So we currently have, the core fabric that works with ONOS. We have a segment routing application that writes down flow objectives, uses the flow objective ONOS API. Those flow objectives are translated at the driver layer using a pipeliner behavior implementation for the OFDPA pipeline. But by working with OFDPA, we realized it's hard to introduce new features and maintain the pipeliner implementation for the different version of DPAs, but also for the different underlying Broadcom chip implementation. So what we like to do is use P4 to design our own pipeline that fits the needs of the core trellis. And the way we want to do it is first we write P4 code that is compatible with the existing segment routing application. So we write both the P4 code and the pipeliner. And then after that, we can optimize it. So he has already been working, he and Jongwon, they've already been working on a draft of the P4 code, Fabric.py, they will share soon. They will also share some design documents. And if there's anyone interested in this work, please make sure to review the P4 code, provide feedbacks, and then we can, organize the development work for the, for example, implementation of the pipeliner, interpreter, and things like that. Okay, so is there any question about this part?
Yes, I have a question. Thank you for the presentation. It's a good idea to have the simple pipeline because I always find the OFDPA pipeline very complex and very hard to understand. So one thing I didn't understand that how the next table matching will work. So I don't know the slide number, but yes.
Okay, so basically the table is following the objective, right? So we have a next ID inside the next objective. So we have a next ID mapping to map the ID to the different types of table. And the next ID is the metadata inside the Fabric.py. And how we assign the next ID by using this kind of tables. So inside the forwarding objective, we have a next ID in the forwarding objective to point to the next control. So these different kinds of table will assign the next ID to that metadata, so we can match.
So this is basically a one-to-one mapping between the flow objective abstraction
from
the actual P4 pipeline, right?
Actually, the forwarding objective, just point to the next objective.
Okay.
By using the next ID.
Okay.
We'll be able to choose next ID by checking which table the packet is matched. For example, if the packet matched in IP version unicast routing, then will I be able to the next IP mapping according to that?
I don't really understand your question, but for example, you want to install L2 unicast, you need to create a forwarding objective with the MAC address and the VLAN for the match, and then the next ID for the next. So we'll install,
So what happens is that you define what you want to do next in terms if you want to do simple unicast forwarding or ECMP like or broadcast directly in the forwarding control group. So there is a one-to-one mapping between the ONOS forwarding objective, right, and what you write inside the tables here, the forwarding control. So I imagine there inside, for example, the IPv4 unicast routing, there will be a P4 action that actually sets the next ID, right?
Yeah.
And then you have to install some rules in the next ID mapping table that sends that specific ID to either the simple forwarding group or the ECMP hashed one.
Yeah.
Okay, thank you.
But I think this will be more clear as soon as Yi shares the P4 code of P4. Okay, so next, because we're running a little bit late, if you have questions,
you can ask me offline.
You can ask offline to Middle English, or maybe speak now very quickly while I make Jong1 presenter. Okay, so I made Jong1 presenter, but GoToMeeting is telling me that Jong1 needs to download an extension.
Using web?
Yeah, probably.
Maybe we can use something like we can share his slide. Oh, he's presenting.
Okay. So next use case is INT. I don't know if you're familiar with INT. INT is a way to collect metrics from the data plane and have them carried inside the same data packet. That's why it's called in-band. There is kind of a specification work inside the p4.org working group. And what we would like to do with ONOS is find a way for applications to easily orchestrate the telemetry generation and collection process. And Jong1 will tell us more about this. So please, Jong1.
Yeah, can I see my screen?
Yes, very well.
Yeah.
Okay. Hi, I'm Jong1. So now I will talk about the INT support in ONOS. So in case of you, the guys who are not familiar with the INT, I will briefly talk about the INT first. So INT is the framework for collecting and reporting the network state by the data plane and used at the packet level. So, and the examples of the network state collect, we call it as a metadata, includes the switch ID and timestamp and link utilization and some kind of the queue data. And these kind of network states are specified in the instruction bitmap here in the INT header. So by setting the bit in this bitmap, you can select what kind of network state you're collecting. And the right figure shows the basic example of the INT working. So for example, if we send the packet from this host to this host. It sends the packet, and from the first switch, it injects the header and corresponding metadata. And at the transit switch, it also injects his metadata to the packet. And at the last switch, it also injects his metadata. And finally, it restores the original packet and forwards it to the host. And the metadata for this packet is collected like this. And I will show you some little more details and interaction with the ONOS. So in terms of the ONOS, it will install 2 flow rules to collect the int metadata. One for the inject the IND header, and another flow rule to collect the metadata. So this is some piece of code of the P4 program of the POC. So here, it matches the metadata called I2E. So if it matches with it is identified as a source, it can run the action called into source. And here we can specify what type of metadata we are collecting. So ONOS can insert these flow rules to the pipeline, and at the last of switch, and there are a table called itsync, and here we just the collected packet to send it to the controller. And this is the POC implementation by me and my colleagues. So before we move on to the ONOS implementation, I will briefly introduce you about the POC implementation based on the old BMP subsystem called Intmon. This is actually my work before I joining into the ONF. So the architecture is like this. So at the bottom, we have the P4 core called Intmon. It's based on the P4 protein, and it includes some kind of codes as I showed you before. And it's a collection of tables with match field and actions. So ONOS will populate the rules to how to collect the int data. And there is another ONOS part called the controller. So the role of this controller is loading the compiled JSON files and install to the BMTC switch. And during the runtime, it populates the flow rules to the old tables. And we have also some GUI to control how to collect the int packets. So we have the filters for the flow rules to select the specific flows to monitor. And also we can choose the types of metadata we are interested. So this is the screenshot of the control interface. And also we also have the monitoring interface to show the collected metadata like this. And if you're more interested in this POC implementation, you can refer to this presentation and also some kind of the technical papers. And from this POC implementation, we found some problems. And first one is actually we implemented a few months ago. So it using the old versions of the software components using the P4 version 14. And also we use the BMP subsystem, which is included in ONOS 1.6, which is quite old version. And also there was, we just faced some performance issue because in this implementation, we just sent all the collected int package to the ONOS instance. So it encouraged a lot of the overhead to the ONOS instances. And it basically collects the packet level metadata. So there was no flow level statistics and so on. And also this is just an application level implementation of the INT using the ONOS. So Next thing is what we have to do. So this is the high-level architecture we just have in mind. So now we are using the very new PI framework to support the interfunctionalities. So the user can provide the INT-capable pipe-conf, and using this pipe-conf, we can install the INT monitoring rules and also specify the metadata types. So, and then instead of the forwarding collected metadata directly to the ONOS, we'll forward the INT metadata to external collector. And here, collector also receiving some metadata from the ONOS itself, for example, the topology information or switch information. And it can be used to generate some flow level or some kind of other levels of data based on the packet level into metadata. And this collector aggregates the metadata and send it back to the ONOS. And its monitoring application on top of the ONOS can use this data to configure, to visualize the collected data, and it can also configure the intermonitoring procedure, and some kind of interface is provided. And on this design, we find some problems. So how to support it in perspective of the ONOS, not in the application level. So first problem was that how is the ONOS aware that this pipeline is INT capable? So the P4 program may support the INT functionality or may not support. So how this ONOS understand that the pipe-conf is INT capable? That's one problem. And another problem is that how do we make apps able to use ONOS APIs to orchestrate the INT data generation and collection process, and what's the design of the APIs? So these are currently the problems that we have. Yeah, so these are actually the last slide we have. So there needs some effort from the brigade and community. So we need the more detailed architecture, and we can port the POC implementation using the P416 and our PI framework. And we need some more details about the external collector. We can combine some kind of open sources, or we can find another candidate of the good software for as an external collector. And also we need some interface between the collector and ONOS. And next thing is about the northbound API designed for the INT, as I said before, to orchestrate the telemetry data generation and collection process. And also we need to find a way to check int capability of the pipeline provided by the users. And actually it's the next step of the work, which is finding a way to utilize the INT metadata, not just showing the monitoring result of the data. And we can find more things to do. And this is the end of my presentation.
Thank you, Jongwan. Thank you very much. If you can go to the previous slide, I just want to reiterate on a very important point. Yeah, the previous slide with the architecture.
This one?
11.
Slide 11, slide number 11.
Okay.
Maybe screen sharing is very slow. I still see slide number 12. Can you move to slide number 11?
Yeah, I moved.
Okay, so yeah, okay, so screen sharing is there's some latency. Okay, I mean I can. So what I want to make sure, I mean, it passes as an important message is what we're trying to do here is not to have a simple POC with a specific P4 problem that supports SINT. What we want to do is offer platform support for any P4 program that is INT capable. So to give you an example, we can take the previous work, fabric.p4, and we can extend that P4 pipeline with INT support by adding INT-specific table. So what we would like to do, we need to find a way for ONOS to understand if a P4 program is INT capable or not. We can do it in a manual way by putting some annotation on the P4 program that ONOS can understand. But we can also find a more automated way. Anyways, once ONOS is aware of the INT capability of a P4 program, then we would like to find eye-level APIs for applications to orchestrate as Jongwan was saying, the INT generation and the generation collection of the INT metrics. For example, specifying which flows we would like to monitor, which kind of metrics we would like to monitor, for example, the location of the external collector, things like that. Right? Optimize all this telemetry collection process. And again, we would like to do this in somewhat program agnostic way. So ideally, any P4 program that supports INT, when I say INT, I mean the INT specification, the P4 INT specification. There's a PDF somewhere, I think, in the P4 repository. Then we should be able to control that. And fabric.p4 is the first example where we can implement INT support and test that support. Is there any question about this part? I know many of you in the brigade are interested in INT.
I wonder how we will integrate with the Fabric P4 and the INT P4.
Okay, so the idea is that maybe initially we can work on parallel. So for example, for the INT work, we can start with a very simple P4 program, maybe with just one table that does basic, I don't know, layer 2, layer 3 forwarding routing, and that also supports INT. So you can imagine, I'm not very familiar with the INT specification, but I imagine there are a few tables that implements the INT process. You have one table that injects the INT header, and you have one table that pops out the INT header and sends the telemetry data either to the switch CPU or to an external collector. So initially we can work in parallel with these two different P4 programs, fabric.p4 and our simple INT P4 program. And at some point we can take the INT part of the simple INT P4 program and augment fabric.p4 with those tables. And as I was saying before, if we create APIs that allow users to bring in any P4 program that supports INT, then we should be able to use ONOS high-level APIs to orchestrate the telemetry generation and collection. I don't know if I answered your question.
I meant, do we have to modify the P4 Fabric program to support INT?
Yes, exactly. Okay. Yes. So INT is something, so the INT data plane processing, it's something you define at the P4 program level. As I was saying before, you need to create a few tables that understands a certain packet header format.
Is it not possible to use different P4 programs and include each other? Is it a right way, or is it not possible?
So initially, I think we're looking at using the INT specification. I don't know if you're familiar with the INT specification.
Mm-hmm. Okay.
Maybe I can show my screen. So if you look somewhere, INT P4 on Google. Yeah. Oh no, the first one, right? So this document specifies, what the header looks like, the INT header, what's the meaning of the INT header. For example, are you tell a switch to append like, for example, the timestamp to the packet or the buffer utilization, right? So there is a specification about this header. So we're planning on offering support for this specification. The thing I'm not sure, maybe Jongwon can answer this question, is that if the specification only specifies what the header looks like, or it also specifies the P4 table that needs to be implemented at the switch. Because for us, the P4 table are important because from the P4 table we derive the runtime API, right, to define the telemetry generation and collection process. Is that something that is specified inside the INT effort or not?
It's not. It just specifies the header types.
Okay, but not the P4 table.
Yes.
Okay, so something. Okay, makes sense. So something we could do is, take the existing INT P4 code, maybe modify it based on our needs, and make this available inside ONOS as a reference INT program. And users, operators who would like to add INT support to their network, they can have a look at this sample P4 program, and augment their P4 programs with our INT API pipeline. This is a first step for sure. Then we might think of a way of supporting different ways of implementing INT in P4.
Okay, got it.
Okay. Is there any question or any other question? We're kind of running out of time here. Personally, I don't have any deadline.
I think another thing was Serhat mentioned that he worked with Accord. So are there any plans or integration with INT?
Yes, I was going to say that maybe we can align this work with the Accord team. So I am also contributing to the Accord, and we can discuss there also this presentation. What are the Accord requirements, and we can generate a design document with your help, with their help part.
Yeah, it will be great. And I think this relates to one of the last points of Jongwon's slides. What do we do with this telemetry data? And I've listened to some Accord presentation, Tom Tawfik talking about this, loop zero, this, way of reusing the telemetry data. So I think that having a feedback from the Accord team in terms of requirements, needs, which kind of, telemetry information you need, that will be great, and will make this work even stronger.
Would it be possible to make the same presentation in Accord's meeting for Jongwon?
I think it's,
or maybe I can do that also. No problem.
Yeah. I mean, we can discuss with Jongwon based on our availability. Okay. Is there any other question about this part, INT? If not, as I was saying before, the idea is to create working groups around these two use cases, Fabric.P4, INT. So after the call, I'm going to send a link to a spreadsheet. I would like people to kind of sign up to one use case, another, or maybe both. And the idea is that maybe next week, in 2 weeks, I don't know, we organize another call in which, each brigade member tells how they plan to contribute, if there are any specific requirements or not. And also would like to have kind of owner for each use case that is able to set somehow deliverables, what we expect, in which time frame, such that we can, make clear what the goals are and when we expect to reach them. And maybe we can discuss this in the next meetings. In terms of other work we're planning to do, we're planning of enhancing the current P4 runtime support. We're currently working here at ONF at things like mastership handling. So how do we support multiple instances of ONOS? Yeah, controlling the same switch. We're working on adding meter support. And this is a work done by Frank Wang. What else? Are we working on anything else in P4 runtime?
P4 runtime, let me think. Also, we need to update the P4 runtime, the version, because there's a bug of the.
Oh yeah, but yes. In terms of capabilities, these are the two main points we're working on. We recently added support for groups, so now we can use groups. Something else I didn't mention is that we are adding support for GNMI. GNMI is a way, as a transport that we can use to configure devices using OpenConfig models. And this is already again a work we're doing here inside ONF. I think we covered there. The main use cases where we really need community help are Fabric.P4 and INT at this point. These are very important, and for this reason we would like to get your help. So yes, I'll send an email with a spreadsheet. We try to create working groups around these use cases. Something else we need help with is documentation and unit test. So if there's anyone in the brigade, the community in general, that is, likes to write documentation, wiki pages, or maybe, who knows, like recording like nice tutorial videos on YouTube, then please reach out to me, to the mailing list. We really need help with documentation. So ideally, we would like to come out with comprehensive documentation, at least in the ONOS wiki, that explains the current support we offer in ONOS for P4. So what's the PI framework we've been talking about? What's this pipeconf? How do we, what's the process for a user that has a P4 program? How can a user use ONOS to control a network program with that P4 program? So kind of like the whole workflow. And also we need that with unit test. Unit tests at different levels. So at the beginning of the work, when we start working on the PI framework, I think we were very good at writing unit tests, but maybe in the last weeks, because of our work was really demo driven, we kind of set aside unit tests. So we would like some help in, first of all, assessing the current coverage of things like the PI framework, the P4 runtime drivers, and the P4 runtime protocol subsystem. First, understand what's missing and where we should to improve unit test, and then we need someone to help developing new unit tests. So if you're interested, please let the mailing list know, or maybe let me know. Yeah, so anyways, I'm gonna send a spreadsheet with 4 columns, right? So there's 2 use cases and documentation and unit tests. And I would like people to kind of like formally sign up to each activity, because the brigade is becoming bigger, and I think it's only beneficial if we find a way to formally organize and structure the work. Is there any question? Okay, if not, I would like to thank you all for joining. We'll talk again in 2 weeks. The call was recorded. We're gonna make this publicly available through the mailing list. And yes, thank you all.
Carmelo, should we make these meetings weekly, because there seems a lot of work here? Maybe weekly meetings not enough.
You're probably right. I thought about this. You know what? Let's try to do it to make it a weekly meeting, so we can meet again next week. I'm gonna send a calendar invite. If it doesn't work, we can always switch back to the bi-weekly format. But I think you're right. At least at the beginning, we need more frequent sync ups. Thanks for the suggestion.
No problem.
All right. Thank you all. Talk in 1 week.
Thank you.
Bye.
Thank you. Bye bye.
Bye.